Colligative properties. So what do we want to put down for colligative properties?
Any property that depends only on the number of solute particles.
Isn't it more of a ratio of solid particles to solvent?
Ratio?
Like how many?
Ratio has an influence on the magnitude of the effect, but we're just talking about what is this colligative property thing mean?
Isn't the change in properties?
Okay, colligative properties are changes in the properties of a pure liquid when a solute is added. And absolutely, you put more solute in there, you're going to get more of a change. But we're just talking about changes. And so we discussed a couple of changes, but what changes do we want to add to this? The solute added to a pure liquid will affect what? Okay, so the freezing point will go down, the boiling point will go up, and what else could you have as an effect?
Usually just might go to a larger liquid stage on the phase.
Okay, these two things together, therefore larger liquid phase. And what else can be affected? Osmotic pressure. You can get flow in and out of a membrane based off of solute additions. If you drop a red blood cell into deionized water, what does the red blood cell do? It's going to explode. Because the concentration inside is infinitely larger than the concentration outside, since there's no concentration outside. So the water will just keep going in, and then the membrane won't be able to handle it, and it'll pop. What would happen if you dropped a red blood cell into, let's say, ocean water? It's going to shrivel up as the less salty inside tries to dilute the salty outside. So the water will leave it. When a salt is added to water, what happens? Why does the boiling point elevate? Okay.
Do you think molecular forces are stronger?
Okay, so intermolecular forces of ions increase the temp. Let me get rid of ions and just put solute. Increase the temp needed to go from the liquid phase to the gaseous phase. So a quick little, can have an H2O and then a sodium with a positive charge, and that oxygen is very attracted to that sodium, much more so than the partial positive, or the partial positive that you would find on another adjoining water molecule's hydrogen. And the freezing point, why is the freezing point depressed?
Because there's less usable water. The sodium and the chloride ions bond with the hydrogen and the oxygen, so they break them all apart.
I like the break them all apart part better.
Disrupts the cellular, disrupts the crystalline structure.
I like that.
Yeah.
Even said like that. If you disrupt the crystal matrix structure, you have a liquid. A liquid is a bunch of molecules that don't have a crystal matrix structure. That's the difference. So if there isn't a crystal matrix structure, you automatically have a liquid. I had a couple questions on this one, but it's a lot easier than it presents itself.
kinda
Is-
figured that
is
out
what I would
by
say.
doing all the math, and then it seemed like all the answers were right there. They're all hopefully right there.
So you take these three containers and you dump them into this empty container, right? So we're looking for the final concentration, so moles per liter. So what we need are moles and liters. I've got a 250 milliliter solution, a 400 milliliter solution, and a 2 liter solution. So when I dump them all into the same container, I've got 2.65 liters of solution. So there's my total liters. So 2.65 liters. Where did I get that from?
In the milliliters, you can read them and add it in.
Yeah, so
Liters.
that plus that gives me 2650, and so 2.65. So what I need are the moles. And so for the first container, there's sodium chloride in it. For the second container, there's sodium chloride, and the third one, it's empty. So there's no moles to add from that. When I dump all three of these in here, whatever moles were in here and whatever moles were in here are now inside of here. So I can actually figure out how many moles are in this container and in this container, and then just add the moles up. So I've got 1.3 moles per liter, and I've got 0.25 liters. And so that is a number of moles in that first container. So what do we got there? 1.3 times 0.25, about 0.25. So I have 3.2, no, I have 0.325 moles of sodium chloride in that first container. And in the second container, I've got 1.75 moles over liters, but I've got 0.4 liters this time. So 0.175 times 0.4. And here I've got 0.7 moles. So my total moles that's in this container now is 1.025 moles. So I'll just put that right there. 1.025 divided by 0.625. And I get 0.3, how many sig figs? 2? Maybe even just 1. All right, I'll just write that. And so it looks like 1 sig fig, so 0.4 for my answer, because of the 400.
Why is it this one?
Because of the 400.
Because it's 400. We okay with that? Which compound is the better electrolyte? Which one?
The calcium chloride,
Why the calcium chloride?
because it completely dissolves.
So does the other one.
Well, leaves
Doesn't matter.
It has, yeah, it has.
All that matters is I get 1 Mg and 1 SO4. That gives me 2 pieces. With the calcium chloride, I get 1 calcium and I get 2 chloride, so I get 50% more power out of that. The charge distribution is the same, but since there are 3 particles that can go to 3 different places, the disruption of the crystal matrix structure is going to be more significant from the 3 versus the 2, even though the 2 both have a +2 charge, or a 2 magnitude charge on the magnesium sulfate. All right, so let's see, what do we got here? What's the percent? Okay, so I've got 35 grams, and I've got 400 milliliters. I'm going to multiply this by 100, and so 3,500 divided by 400, I get 8.75%. It should say that after your percent, mass divided by volume. If you see anything sold as percent, it should have a percent next to it, and then there should be volume to volume, mass to mass, mass to volume. One of those 3 things should be there.
Does percent, that doesn't, sig figs don't affect percent.
They do. It should be 1, 9.
Okay.
Or I should just be more,
You mean when
On
we
it.
answer like that, we'll have to do that?
you'll have to put that parentheses. And why is it mass to volume?
Because that's what our,
Because you have grams in it.
I have grams mass unit and milliliters volume unit. Yeah. If it was milliliters and milliliters, it'd be volume volume. If it was grams and grams, it'd be mass mass. What's the volume of alcohol in 454 milliliters? We are at 3.5. Okay, so this time we know the percent. Yikes. So I'll go 3.5% equals 100, and it's and 454 milliliters. Since it's beer and alcohol, it's got to be a volume one, right? Because the ethanol and the rest of the beer is basically water, the solution, so it's two liquids. So I'll have 3.5 times 454 milliliters divided by 100. And then, so 3.5 times 454 divided by 100. I have 15.89 milliliters of ethanol. So 16 milliliters for your answer. Does anybody know what beer that is? It's Guinness.
So you said you only put the mass volume or volume
Oh,
volume if it's
no,
a
no.
percent, right?
Right. Yeah,
Okay.
yeah. So on that problem it gave you, it said volume.
Okay.
And anytime you see a percent down, there should be something in parentheses with the ratio of what it is that you're talking about. So if you go to the grocery store and you buy hydrogen peroxide, it should say volume next to it, or per volume, by volume, something letting you know it was a volume thing. They may or may not actually do that, but they're supposed to. They're supposed to be labeling it in that manner. Which equations did you use for the previous two? So we used mass to volume percent, and we used volume to volume percent. What is the freezing temperature, the Fahrenheit freezing temperature of this solution? Okay, so the equation for this is the change in temperature of the freezing point is equal to the n factor, which is the particle number, times the Kf, times the molarity. It's really hard to look at the board and write at the same time. So what's this value right here?
2.5.
No, it's 3. Where'd that 3 come from?
When you break down your.
So this is magnesium chloride, right? So just like before, it's going to bust into 3 pieces. So this is a unitless number. It's just telling you how many particles you're going to get when I dump in the magnesium chloride. So this will be just 3. And then the Kf was given at 1.86 degrees C molar. And then we were given 2.5 molar for the concentration. So I've got units of degrees C. And so I got 7.5 times 1.86. So 13.95 degrees C. So this is the, make sure you answer the question part of this question. So this is, what is this number here?
That's the change in temperature.
Okay, so tell me what the freezing point is in Celsius.
6.89.
Negative 13.95 degrees C is the new freezing point in degrees C. So what is it in Fahrenheit? Now you just plug this number into the Fahrenheit equation. So it's, what is it?
Fahrenheit equals 9 fifths times C plus
Plus 32?
Plus.
Plus 32? Well, let's see if that's right. 9.5 times 9 divided by 5 equals plus 32 equals, no. That's not right. Oh, wait.
Yes, it is.
Just a sec. Negative 13.95 times 9 divided by 5 equals plus 32 equals. Okay, that looks good. So this answer is 6.89 degrees Fahrenheit. Since I have two sig figs, we'll go with 6.9 degrees Fahrenheit. Do those two numbers, are you okay with those? Is everybody okay with me saying it's 13.95 is the change? So how did I know that it was negative 13.95 for the degree C for the change in the freezing point?
Because it drops.
It only can ever go down. The freezing point will only get colder. So if this is the change and it's 0 for Celsius, then this must be the number for Celsius. And then you just have to plug it into this equation. And these two numbers are equivalent to each other. So I better have a temperature in Fahrenheit less than 32, significantly less than 32, because almost 14 degrees Celsius is like a third of body temp, right? More than a third of body temp, so it better be a significant change. Okay.
So if that would have been boiling, then it would have been a positive number.
Yeah, if we would have been talking about the freezing point or the boiling point change, it would have been a number, this would have been 113.95 degrees C, and then it would have been 240-ish or something like that degrees Fahrenheit, for sure. Yeah, I was just trying to make sure you remembered to convert and remembered that its freezing point always goes down in this case, and then the converse, the boiling point would always go up.
Rob, these